Welcome to today's session. Today we are going to cover some differentiation problem where we are going to mainly focus on some numerical problems such as this one. There is a curve y is equals to 7 minus 2x to the power 5. It means the curve is look like this one. So this is the center of origin of a graph and this is the 7 point. So this is actually 7 and whatsoever the red line actually the curve, right? Very first question A, what is the first order differentiation of this function? So d of dx, because the function is y, so dy over dx is equals to d over dx 7 minus 2x to the power 5. So it will be 0 because any constant term when we differentiate value is 0 minus 2 dot x to the power, by the way it will be 5 2.5 and x to the power 5 minus 1. Why? Because if x to the power n, if we differentiate this term with respect to x, then n dot n minus 1. This formula we are applying here. Indeed, what we have got minus 10 x to the power 4. This is the first question and this is the final answer of the A number. Now B, find an equation for the tangent to the curve at point where x is equals to 1. So x is equals to 1 where? So this is 1, this is 2, this is 3, this is 4, right? So somewhere point x is equals to 1, at that point we have to find an equation for a tangent line. It means that we have to find a straight line of a tangent which on actually a tangency of this curve that we have to calculate. Indeed, first of all we have to find the equation of the tangent. So the equation of tangent at x is equals to 1. So find the point actually. So find the point on curve. So y is equals to 7 minus 2 and the value of x is equals to 1. So 1 power 5. So we have y is equal to 5. So the point, find the point. So point will be 1 comma 5, right? And if you'd like to find a straight line, we have to have a point, and obviously we have to find a equation for the straight line. It is very essential when we have slope as well. So now it's time to find the slope of the straight line or the tangent line. So slope at x is equals to 1. So d over dx, actually dy by dx is equal to minus 10 x to the power 4. This is actually the slope. Any function when we derivate or derivation of first order, that is actually the slope of that function. So slope is nothing but dy by dx of the function, and this is the value of the slope. Now use the slope and the point, the tangent equation or the straight line equation, tangent equation, it is actually a straight line equation. So the straight line equation, when we have got the slope and point, write down y minus y1 equals to m. M is actually the slope, so this is the value of the slope, and x minus x. This is the very fundamental rule or formula of a straight line or the tangent line of this question. So let's plug in the value. So it will be y, and value of y1 is also actually 5 because the value of y is 5, so it will be 5, and the value of m is nothing but minus 10. Why? Because when we plug in the value of x is equals to 1, because at x equals to 1, so if we plug in the value of 1 here, then it will become actually minus 10. So the slope actually minus 10 and x minus the value of x1 is equals to 1. If we simplify the equation, we have y plus 10 of x is equals to 50. So this is the answer of number B. It means that the tangent is actually at 1 comma 5 point, right? So where is actually 1 comma 5 point? So this is the 1 comma 5 point. So the tangent, probably this is the equation of a tangent, right? Anyways, we're not bothering the equation. Now question number C. So what is the question C? C is determine whether the value of y is increasing or decreasing when the value of x is equals to minus 2. Now we actually clarify or verify the value of y is either decreasing or increasing, that we have to determine. So either increasing or decreasing. At what point? At x is equals to minus 2. So dy of dx is equals to minus 10 x to the power 4. Now if you plug in the value of y is equals to minus 2, so we have got minus 160. Just plug in the value of x is minus 2 to the power 4. So obviously this is even number, so it will be positive, right? And 2 to the power 4 is 16, 10 times 16 is equals to 160, and this is minus, so it will be minus. And minus 160 is actually less than 0, right? And if dy by dx is less than 0, indeed the function is decreasing. If dy by dx is greater than 0, it means the function is increasing, right? Now, if there is a question for this curve, we already actually find out the point where actually the tangent, so this is the point of tangent, right? So this is the point of tangent. So this is the tangent point at the point of 1, 5. But if there another question at D might ask, where is the tangency point, right? Or is it true that 1.1, 5 is a tangency point for the curve? Indeed, what we have to do, so for better understanding, let's write down a title: tangency verification or clarify verification, right? So slope dy over dx is equals to minus 10 x to the power 4, right? And what is actually the value of slope? Slope is actually minus 10, right? Minus 10. So if we can write down, so the value of the slope is actually minus 10 is equals to minus 10 x to the power 4. Or we could write down x to the power 4 is equals to 1. So the value of x is equals to plus minus square root of 1. So we could say the value of x is equals to plus minus 1. So here actually the value of x either positive or may be negative. Let's have a look on the graph. So in the graph, here is the point, and maybe another point on the negative side of x is equals to minus 1. So maybe this point. But let me check, or let's check whether this point is correct or maybe this point is correct, right? So x have a point like positive 1 or maybe negative point, but we have to find the value of y as well. What is the value of y? Anyways, so whether x is equals to 1 or x is equals to minus 1. So this is case number 1 and this is case number 2. So y is equals to 7 minus 2, value of x is equals to 1 to the power 5. So here 7 minus 2, so we have got the value of y is 5. So the point will be x comma y is equals to 1 comma 5. We already know this value, right? Now verify this value as well. Y is equals to 7 minus the value of x is equals to minus 1. So plug in here 1 to the power 5. By the way, it will be 2 here. So the value will be, so here 7 minus, and it will be minus 1. So minus 1 times 2 is plus 2. So the value of y is 9, right? So the point is 1 minus 1 comma 9. And we know, we already actually find out the value of the tangent line y is equals to minus 10 of x plus 15, right? The tangent line, where the tangent line, this was the tangent line, remember, this was the tangent line. So now if we plug in the value here, so y is equals to minus 10 times 1 plus 15. What we have? We have got 5. And for case 2, the value of y minus 10 and the value of x is actually minus 1 plus 15. What we have got here? Plus 10 and 15, right? So we have got here 25, right? Which is not actually correct, because here we have got 9 and here is 25. So the final comment for the problem, the line y is equals to minus 10 of x plus 15, that is actually the tangent line, right? The tangent line, this is the equation actually, which is touches the curve of this one at the quotient at 1.5, and this 1.5 is the point of tangency, right? So let me check, or just a cross check actually here. So at the point 1.5, the tangency, and this line is actually the tangent line. So the tangent line y is equals to minus 10 of x plus 15, right? So this is a straight line equation for the tangent line. Thank you.